Welcome to part 3 of Competency 14. In this video, we will work with the coordinate plane and geometric properties. Number 1. In triangle ABC, the coordinates of A are 1, 3, and the coordinates of B are 13, 11. If angle A is a right angle, what is the slope of AC? Okay. The whole point of this particular question is, one, we should know this particular detail. Okay, they're saying that angle A is the right triangle, and they had to give that to you specifically because generally the right angle would be the center B. So they're telling you because they're saying, hey, this is our right angle. Okay, that's fine. So they give you A. In A, we could say that we have A and then B. Doesn't matter what the values are. Okay. But then because this is a right angle, we know it's going to come down. If I could draw, it'd be great, but pretend like I can. Okay. And that's A. Okay. This means whatever the slope of AB is, then the slope of AC will be the negative reciprocal. Okay, so if we can get the slope from A to B, then we know what to do to get the slope of A to C. So we need to figure out that slope. Well, we just use our slope formula. So remember, slope is rise over run. So we need the distance from 11 to 3. So we have 11 minus 3. And then we need the run, which is the distance from our x, our 13 minus the 1. Okay, if you remember this slope formula. Okay, and of course, that gives us, oh my goodness, never been the best at this. That gives us 12, oh, no, 8, the other way around, 8 over 12. Okay, 8 over 12. All right, so then that, of course, reduces down to 2/3. But that is the slope. So let me highlight this. This value goes with that slope. Okay, so what do we need to get? Let's change our highlighter. Okay, now we need the negative reciprocal. Well, that's easy enough. Slap a negative in front of it, flip those numbers over, and what do we have? We have this guy right here. Okay, slap a negative and reciprocal them, and we're good. Okay, and we're done with that one. All right, let's look at number 2. In an isosceles triangle DEF, DE is equal to DF. If the coordinates of points E are as thus 3, -7, and the coordinates of F are 23 and -3, what is the slope of the altitude of D? Okay, we are again using the same properties, applying it to a different situation because an isosceles triangle has 2 equal right triangles. You fold it in half and you have right triangles. So if you think about it that way, well, then we just need those 2 slopes. So let me show you. I'm going to do this differently. Since numbers 2 and 3 actually go together, I will draw this for you. I'm going to draw the dots, and then I have more to help you out with this. So we'll take this a little further, which is unusual for me. Okay, so what do we need? we need those points of 3 and -7, okay, which is right here. And that guy is labeled as E, okay? And then we have F, so that the next one, 23, which we have right here, 23 and -3, 1. So it's right here. Okay. Couldn't call that guy F. All right. So what we're doing here is whatever that slope is, then we just do the negative reciprocal. So basically what's going on is we're going to have some guy over here in the middle. He's going to have to be in the center. So I bet it's right here if I could draw. And then we'll have to have a perpendicular line. Okay. Well, of course, this all hinges on if I could draw. Okay, we're going to say that's perpendicular. Okay. So what they're asking us is, what is the slope of the altitude of D? Somewhere out here, magically, there's a D. And halfway, and I'm jumping ahead to number 3 just a little. Somewhere, this is this midpoint. This is mid. Okay. And then let's go back to the colors. That means this and this. There are little hash marks. They're equal. Okay. So we have something like this. Now we could draw that, let's say, upside down from what I have. It still works. Still the same thing. Okay. So this means what is the slope? So I need my distance. Well, I've drawn it, so I'm going to cheat. I'm going to say rise over run. So what do I have here? Well, if I take 23 over here, do a highlighting. Take 23, subtract the 3, that's my run. And my rise is 1, 2, 3, 4. Okay, so we have the rise is 4, the run was 20. That is 1 over 5, right? Okay, now what do? We want the negative reciprocal. Okay, well, that's going to be C. Okay, now I've done all this effort to draw my isosceles triangle and give it to you. And then number 3 says, using the information from question 2, if DH is the altitude from D to H, what they're telling us is, hey, uh, you know what I'm just going to do? Let's do this. That's switch. They're saying this midpoint is H. It has to be the midpoint. Those are the properties and definition of an isosceles triangle. Using that fact, we can count and find that midpoint. I mean, you could take the distance, cut it in half, but I'm looking at this. So if I go over, I'm looking at 13 and -5, which would be B. Okay. Now I have something a little different. I know that I've drawn all this. However, I have added a link underneath this, and I'm going to delete everything I have, and let me show you what I have. And then I'll show you this in GeoGebra so you see the moving parts. This is a little bit better drawing, a little bit better diagram. I know I drew all that in, but that shows you all the finer points using a better graph, GeoGebra. When you're taking a test, you're going to have to draw these things. You're going to have to know how to do them. Okay, then let's flip the slides and I'll show you what this looks like in moving parts and how it could look differently. Okay, this is our diagram, but we put it in GeoGebra, and I've made it movable. So we have our altitude, and as you see, I can change that distance from D to H. I can also be just as correct by drawing the isosceles flipped over, as long as my my distances are equal. Okay, here it's 11 and 11. Okay, now the brown represents how the slope would be. And notice there is our -5 value of our slope, and then our reciprocal 0.2 is 1/5. So that would be the slope from D to F. So it gives you an idea of what happens. Now, of course, these are estimates. Uh, I did the best I can. We have the little light green dotted line, that's J. That's our perpendicular. We're holding true to our 90 degrees. There's our midpoint value, our H. See that number 1 there also? Those are our slopes, the brown. That shows the two slopes and how they're related to each other, and the other measurements to help us get the values that we needed. Okay. Number 4, in right triangle JKL, the angle of K is 90 degrees. The coordinates of J are -9, -3, and the coordinates of L are -7, -10. If JK equals 6, what is the value of KL? Okay, we'll put this in the graph. Go ahead and draw this, construct it, and then you'll see, because it's right triangles, we just apply the Pythagorean theorem a couple of times, okay? All right, and as I stated before, this angle of K is our right angle in the middle. So this tells me that JL is the hypotenuse, okay? And we need the distance of it. So anyway, we have enough to find the distance of the hypotenuse and then use the hypotenuse and the leg we're given, leg measure, to find the distance that they asked for in the end, okay? It's a bit of a process. Okay, so we have -9, -3, and that is J, okay? Let's go up, and then we need -7, -10, okay? And that is L, okay? Now, we'll go ahead and draw this. I'm not saying I'm the best artist in the world, but somewhere out here from L, we will have a distance of 6 units, okay, somewhere out there in the abyss. And then this will create a right angle, and we will call this point K. All right, somewhere out there with this right triangle. Right, so how do we find, okay, we have 6, that's a leg. Now we have from J to L, that is a hypotenuse. Well, we can find that by applying the Pythagorean theorem the first time. Okay, so that means that my distance from J to L is going to equal 7 squared plus 2 squared, which means that we have 49 plus 4 square root of 53. So that's the distance of J to L. So let's pencil that in. Square root of 53. So just apply the Pythagorean theorem again to get the distance from J to K. Makes sense. So this will be, okay, that will be under the radical 53. We're going to have to square it. Oh, then we're subtracting. Remember, when the hypotenuse is used, we subtract the square of the other leg, which is 6. Okay, now we need to remember something, that we have a plus, minus, always under the radical. Let's think about this. Are we going to apply that negative value like we did on the other example that we did? No, because we're dealing with distance. Okay, we don't need to worry about some of that right now. So what does that mean? That means we have 63 minus 36, okay? So what we are using is under the radical of 17, we're using the positive value of that. So let's put that in the calculator and see what we have. Second, go to the square root, pop in 17, and that gives us our correct option. Let's go down, and that is A. Okay? Number 5, 4a squared, m n p q, the coordinate of m, which is already penciled in for you. 1, 4, if the coordinates of n are 5y, that means you can estimate it here, but we really don't know what it is. This is 5y, okay? And the area of the square is 64. Well, that's supposed to be 8. Sorry. If I could. Okay. All right. So that area equals 64 units squared. So what does this mean? We've already prepared. Now, in a test, you will not get this. Highly unlikely this will be graphed out for you. I have done this for you so I could show you quickly and not have to give you some drawing you don't understand. Okay, so what have I done? I used the distance of m and n, which is 8. It is a hypotenuse. I drew this right triangle for you. Please notice that there is a line along x equals 5. This green line is x equals 5. Okay? And that green line gives you guidance. Okay? What we need is from the x-axis, that distance is from here to here. We can judge this. Okay? That is 4. But we know that's 4, but we need to add on the distance from this A to N. We simply apply the Pythagorean theorem again. It's very useful. And we get that leg distance. Okay, so what is that? So we have that as equaling under the radical. That will be 8 squared minus the 4 squared. And that comes out to be 64 minus 16. Okay, which we know is 48. Now here's the thing. I mentioned earlier that when we're pulling something out of the radical, we could have what? You can have positive or negative. So I need to rethink. Oops, I need to rethink this right here. See, I really don't like it when you're using images. When you write, it does this bit here, but that's okay. So really what we need is it equals plus or minus 64 minus 16. So that's plus or minus the 48. That's really what it's going to equal, okay? So that tells me that for the full distance, I need to take this 4, and it is plus or minus 48. That gives me option A. Now you may say, wait a minute, but our image is in the first quadrant. Go up there to your question. Does it say anywhere that y has to be positive? No, it does not. The truth is, I could have two options. I can have what I've given you and what's drawn, or I can use y equals 4 right here, this line, and reflect this entire square over. And y could also be down in the fourth quadrant. Okay, so there's also something else I need to show you. So let's go put this in the calculator. A is our option. But what else could they have done? How else could they have given us answers or asked this question? Which I've seen it done this way before. Here's something else. Let's say 4, okay? Let's say plus. I'm going to add it to under the radical R48. And I see an answer that looks like this. I'm going to highlight it. But it's not correct. Why? Because we have another value, okay? Because they did not specify in the question where the which quadrant we're in, which value is necessary. So we don't know that because we're not dealing with distance. We're dealing with an actual point. That's the big difference in this. We're not, it's not distance, it's a point value. Okay, that being said, I'm going to go up. I'm going to grab this and I will change that plus to a minus. See what it did? Very convenient. And there we go. Okay. And we have that answer also. So yes, if they combined these two together, they're both correct. And it is the same as option A. So be careful. Those could be called lost leaders and because you don't fully understand the question. Okay. Just take all those things in mind. Okay, number 6. In rhombus RSTU, the coordinates of R are 6, 7. That's right here. Okay. And the coordinates of T are 14 and 2. That's right here. Okay, again, this was not provided. The diagram was not provided, just to let you know. Okay. I have worked out the diagram, so we aren't here all day explaining this, okay? At this point, you should have enough education behind you that you can kind of see what I'm doing. Okay, so if SU is equal to 16, that is here, okay? And how do I know that? We could call this S, and we could call this U. How do I know that that's SU? Well, that is the properties of a rhombus. And they're saying, what is the area of the rhombus? Okay, what you do is you take the midpoint of the line, the green line, here to here. And then you have a perpendicular line, which we already know this should be 8 and 8. It must be 90 degree perpendicular midpoint for the rhombus, okay? And not only that, all the sides, notice, they're all going to be 9.29. Okay, rounding, okay? So you have some things here. I'm going to put 3 marks on this one, okay? 2 on these. You have some things going on here where things have, that certain segments must be congruent to each other for it to qualify as a rhombus. Okay, that being said, that means that if I get the distance from 6, 7 right here, my green distance, which I already have, it's about 9.4 threes. Let's do this on the calculator so we come out with a good amount. Okay, so what have I done? I used my diagram and the Pythagorean theorem. So I had 5 and 8. Put that under your square root. Okay, we're getting the distance of the green hypotenuse. Okay, all right, underneath that, I need 5 squared plus 8 squared. Okay, and that gives us an estimated 9.4339. Okay, that's in the diagram. It's there. It's estimated. But let's use what's in the calculator so we get a better value. Okay, now for the rhombus. The rhombus has 4 congruent triangles. To get that area, what do we need? Base times height. Think about, look at it. Move around those triangles, and what do we have? We have, here's 2 triangles put together. So 8 is our height, and our base is actually the green line, the 9.434 that we just put in our calculator. So if I say times 8, I will have the area of the rhombus. So let me highlight in green what I mean. I will take this triangle and this triangle. If I move them up here, okay, see what I'm doing? Flip them over. Then they actually make a nice rectangle. Okay, if you know that this here, this probably makes it confusing, but I'm going to shift those up. Take another look at it, stop the video, draw it out for yourself, and you'll see that option B is actually the area of that particular diagram. Number 7, in a parallelogram WXYZ, the diagonals, that's important, intersect at V. The coordinates of W are -2 and 4. So this has an A there. That's actually W. Okay. Intersect at point V. Let's see here. And the coordinates of X are 12 and 4. So this is actually X. Okay. And then it says that and V, the coordinates of V are, this is V. Okay. Right. That's where they intersect. What are the coordinates of Y? Okay. So what does that give me? Well, if we're talking diagonals, that means that I have a diagonal that's going to go from here to here, okay, and then down. Thought I had that turned off. But I'm going to have to go down the other direction. But they're asking me, let's see, this is W. W, X, Y would be next. So let me show you what I'm doing here. If I go from here to here, okay, Y, it would be opposite from W. Here's W, here's Y, okay? So X would be in between, all right? So let me follow through here. That means I'm going from here to here. Now I need to draw another one of those to get at the other end. Okay, so I have 1, 2, 3. So my rise was 3, so I go down 3, and my run is 1, 2, 3, 4, 5, 6. Go over 1, 2, 3, 4, 5, and 6. So I should put my dot right here, and that follows through. Pretend like I can draw, okay? I didn't have a nice, pretty diagram for this one, but I know that that is actually the coordinates of Y, and those are 10 and -2. And that is option C, which is correct. Okay, now let me draw this in for you. Okay, That means that if I use the same techniques, well, I will have a rhombus. Not a rhombus, but a parallelogram that goes from there to there. So I have to count how many spaces. Let's see here. That's 12, 13, 14. So I need to go 14 this direction. Well, I know that's 10. I go 4 more, and that should do it. Okay? All right? And you know what? I should make my diagonals a different color at least. Going through there and here and here. Okay. Well, let's shake it up a little. Oh, that is if I can draw. All right, let's pretend. There's a lot of pretending with my drawing. That's not too bad, okay? So that gave us C as the option for 7. Well, let's look at 8. It says use the information from 7. What is the area of WXYZ, which is our parallelogram? Well, that's just base times height. Well, what is our base? Well, that is 10 and 4. Well, that's 14. So here, we'll change that so we can actually read it. So 14 is our base, and that our height is right here. I'm going to highlight that in. This would be our height right here. So we have 1, 2, 3, 4, 5, 6. So 14 times 6. 14. Oops. 14 times 6. And what do we get? 48. 48 square units. And I agree completely. Okay. That's our last question for this video. I hope you like what we're doing. If you do, please give us a like and share us with anybody you know that needs to study. And don't forget, subscribe so we can keep these coming and keep the channel up. Happy testing!